I hope all of you are doing good. Let's start today's chapter, triangles. But first, let's do revision. Polygons. Consider the above figures. Figure A and B are bounded by line segments, as you can see in the picture, right? And are called polygons. Figure C and D are non-polygons because these two figures are not bounded by line segments, right? So, a closed figure bounded by at least 3 line segments is called a polygon. The line segments which form a polygon are called its sides. The point of intersection of the side of a polygon are called its vertices. Different types of polygons are described below. See, triangle. A triangle has 3 angles. It has 3 vertices. Correlator has 4 sides, right? Pentagon has 5 sides. Hexagon has 6 sides. Heptagon has 7 sides, and octagon has 8 sides. Okay. A polygon having number of sides is equals to number of angles is equals to number of vertices. Okay. From the above, we note that the number of angles of a polygon is equals to the number of its sides, and the number of vertices of a polygon is also equal to the number of its sides. Okay. Now let's talk about triangles. Consider 3 non-collinear points PQR. Non-collinear points means which are not in a same line. Okay. So if we join the point PQR, we get a closed figure bounded by 3 line segments. This is called a triangle. A triangle is made up of 3 line segments only. See, 1, 2 and 3. These are the 3 line segments. Elements of a triangle. In the above figure, triangle PQR is a triangle. See, this is the symbol of a triangle. Okay. The line segments PQ, QR and P are called its sides. In this triangle, P, Q and R are called its vertices. The angle included between 2 sides of a triangle is called an angle of the triangle. Angle PQR, angle PQR, okay. Angle QRP and angle RPQ, okay, are 3 angles of triangle PQR. Angle P is the angle opposite to side QR. As you can see, angle P, this angle is opposite to the sides QR. Okay. The 3 sides and the 3 angles of a triangle are called the 6 elements of the triangle. Now let's talk about the properties of triangle. Property number 1. Sum of the 3 angles of a triangle is equals to 180. Okay. So consider the following 3 triangles. Okay. If we find the sum of all these 3 angles, we will find that sum of these 3 angles is equals to 180. Okay. Measure the angles of the respective triangles with the protractor and note down the measurement in the table given below. Okay. It is given here. We observe that sum of the measure of the 3 angles of a triangle is 180. Okay. Now property 2. The sum of the length of any 2 sides of a triangle is greater than the length of the 3rd side. So we can verify in the following way. We draw 3 triangles ABC, PQR and DEF and measure all the sides of a triangle and write them in the table that follows. Okay. So what we have to do is, student, you will take a ruler or a scale, you will measure the length of these sides, you will write over here, and then you will find what is the sum of 2 sides or length of the 3rd side. For example, this is a triangle, 4 centimeter, this side is 4 centimeter, 3 centimeter and 2 centimeter. Okay. Take any 2 sides. A, B, C. Take any 2 sides. AB plus BC should be greater than AC. Okay. So, AB plus BC is 4 plus 2 centimeter. Is greater than AC is 3 centimeter. So, 6 centimeter is greater than 3 centimeter. Or you can take these 2 sides also, or you can take these 2 sides also. So, you can take any 2 sides. Okay. The sum of 2 sides should be greater than the 3rd side, right? Now, sum of 2 sides is always greater than the 3rd side. Now, classification of triangles. Triangles can be classified in the following 2 ways, according to sides and according to angles. Number 1, classification of triangles on the basis of their sides. Equilateral triangle. A triangle whose 3 sides are equal is called an equilateral triangle. Look at this figure, all 3 sides are equal, okay, and all angles of an equilateral triangle are equal, right? Isosceles triangles. A triangle whose 2 sides are equal is called an isosceles triangle. In the adjoining figures, see PQ and PR is equal. It is an isosceles triangle. On measurement, we will note that angle Q and angle R, these are also equal. Thus, 2 sides of an isosceles triangle are equal and the angles opposite to the equal sides of an isosceles triangle are equal. For example, this angle is opposite to this side and this angle is opposite to this side. So these two sides, these two angles are equal. Okay. Next is a scalene triangle. A triangle which has three unequal sides is called a scalene triangle. In the adjoining figure, ABC is a scalene triangle and none of its sides is equal. Okay, all three sides are unequal. So on measurement you will find that these three angles are also not equals to each other. Thus in a scalene triangle, no two sides are equal, no two angles are equal, right? Number 2, classification of triangles on the basis of measures of angles. Right angled triangle. A triangle is called right angle if it has an angle of 90 degree. In the adjoining figure, angle Q is 90 degree and it's a right angle, right? The side opposite to the right angle is called hypotenuse. See, side opposite to the right angle. This is the right angle, this is the opposite sides, and this side is known as, called as hypotenuse. Okay, PR is a hypotenuse. Next is obtuse angled triangle. A triangle is called obtuse angle if it has an angle greater than 90. Okay, as you can see in this figure, triangle ABC, angle B is greater than 90 degrees. So it is called an obtuse angled triangle, right? Next is acute angle triangle. A triangle is called acute angle if all its angles are acute. Okay, in the given figure, PQR is acute angled since all its angles are less than 90 degree. Okay, now let's do exercise 21.1. A closed figure bounded by at least 3 line segment is called polygon. Yes. Okay students, now you will do practice of this exercise. Okay.